Welcome to this lecture. In the last lecture, we had just started to discuss about the bridge pattern. The bridge pattern is an extremely useful pattern, helps to simplify the design, makes it more maintainable, extendable, very popular pattern. Let us look at this pattern. If you remember, we were discussing towards the end of the last lecture the structure of this pattern with the help of some examples. Let us just recollect the structure of the bridge pattern that we were discussing last time. We had taken the example of a shape, various types of shapes, geometric shapes, line, triangle, circle and so on. And then these are to be drawn on various platforms, on the desktops, mobile phones and so on. And then we had discussed about the class hierarchy that kept on becoming more and more complex as we used a different application like animation or we used a different platform. And the solution to that we had drawn the bridge pattern. Here on the left side of the pattern, we have the abstraction hierarchy. These are the general concepts which typically do not change too much. On the right side, there is another hierarchy which is the implementation hierarchy, and here it is more likely to change as new platforms become available, new applications become available and so on. And we had said that the number of classes here, if we use bridged pattern, is quite manageable, understandable. But if we do not use the bridge pattern, just use a class hierarchy as it is, then the number of classes grows very rapidly and becomes very complex. Here the client interfaces, the client class interfaces with the abstraction here, the abstraction hierarchy, and then as the client invokes the methods and the abstraction, maybe to reshape, maybe to edit, move and so on. If required, the shape calls the corresponding concrete implementation class. We will see the details of this class in using more number of examples, but this was the main idea that we are trying to discuss in the last lecture. So, here the main idea is that we do not use a single hierarchy where both abstraction, if there is a change to the abstraction or change to the implementation, these are handled uniformly in the same hierarchy. Rather, in this pattern, if we use the abstraction hierarchy is separate from the implementation hierarchy, and any change to the implementation hierarchy, we just make that change without affecting the other hierarchy. So, this side, the left side is the abstraction hierarchy and the right side is the implementation hierarchy. But then why is the name bridge given to this pattern? The name bridge is given because this pattern provides a bridge between the abstraction hierarchy and the implementation hierarchy. So, this is the abstraction hierarchy where the terms line, rectangle, etc., these are invariant with respect to the specific implementation, whether it is a desktop, whether it is a smartphone, whether it is a embedded application, whether it is a animation, we still call those as line and triangle because these are application domain terms. On the other hand, on the implementation domain terms, we have high resolution, low resolution, transient view and so on. So, this pattern separates out the abstraction hierarchy from the implementation hierarchy and provides a bridge between the abstraction and the implementation, which is basically a association or a aggregation relation, which helps the application class to invoke the methods of the implementation class. We can redraw the structure like this, the same one. Here the abstraction is a abstract class and many operations are defined. The refined abstractions are concrete class. These are application domain classes. The client invokes the abstract class here, to which the corresponding concrete class is bound, and then the implementation is a interface, and depending on the type of platform and so on, there are different implementation classes here, and the correct implementation class should be bound to the abstraction. If we look at the participants of this pattern, we have the abstraction, the refined abstraction, which are basically concrete classes in the application domain. The implementation is a interface, and then there are concrete implementations, which are basically classes defined on platform variations and so on. The abstraction defines an abstract interface which the client uses, and it maintains a reference to the implementer, and that is how the bridge is established. The refined abstraction is a concrete class which extends the interface defined by the abstraction. The implementation or the implementer, this defines the interface of the implementation class, and the concrete implementer are the concrete classes which are implementation specific, and they implement the implementer interfaces. Here, as the client invokes a method on the abstraction, it may do some work and also, if necessary, forward to the implementer object, the correct implementer object. The clients only interface with the abstraction class, they do not interface with the implementation class, and the abstraction class forwards any request to the implementer class. Let us take few examples to understand the applicability of this pattern. First, let us look at a window example. In the window example, let us say we had two window types. The Microsoft window, MS window and the Mac window. But then after some time we had the need for icons and we defined a special type of window called as icon window. But then the icon window must be implemented on both the MS window and the Mac window, and therefore, we subclassed the Mac icon window, made it MS icon window and the Mac icon window. And similarly, we might have other platforms, for example, Android platform, and then we not only add a class here Android window, but also we will have to add the Android window here. Similarly, Unix window we will also have to add here. So, each time we make a change, we make multiple class additions are required. There is a single class hierarchy and we have not separated the abstraction from the implementation. That is the problem. We have not used the bridge pattern. To be able to use the bridge pattern, we must identify what is the abstraction here and what is the implementation. The abstraction are the different types of windows. For example, the icon window, the application window, these are the different types of windows and their implementation, whether it is in the Microsoft platform, Mac or maybe the Unix platform, Android and so on, those are the implementation. If we consider that, then the application of the bridge pattern becomes very simple. We have the abstraction on the left side. There are two main types of window concepts. One is application window and one is the icon window. Each icon has its own window and the application window has many icons and other things. So, this is one type of window and this is another. These are two basic types of windows, but then these can have implementations on various platforms. So, we have the window implementation, that is the interface, and we have various implementations of the window implementation, that is Microsoft window implementation, Mac window implementation, Android window implementation, Unix window implementation and so on. So, we have separated out the abstraction hierarchy from the implementation hierarchy and have successfully applied the bridge pattern. Now, let us look at another example. We are given this hierarchy which some designer has come up. So, he has the thread scheduler class here and then he subclassed it into preemptive scheduler and time slice scheduler. And then there is the Unix preemptive thread scheduler, the Windows preemptive thread scheduler. There are two types of preemptive thread scheduler, one for the Unix platform and another for the window platform. Similarly, for the time sliced thread scheduler, we will have two subclasses, the Unix time slice thread scheduler and the Windows time slice thread scheduler. But later, as maintenance was required, it was used for some time and then new requirements arose, and then we need to support the Java platform. And once we tried to support the Java platform, we saw that we not only should have a Java JVM preemptive thread scheduler, but also the JVM time sliced thread scheduler. So, the hierarchy becomes more and more complex as new changes occur to either the abstraction or the implementation concepts. We need to apply the bridge pattern, separate out the abstraction and the implementation and provide a bridge between that. Now, what is the abstraction here? The abstraction are the different types of thread schedulers. It is very easy to see here a simple example that there are two basic types of thread scheduler. One is the preemptive scheduler and the other is the time slice scheduler. But then their implementation is different on different platforms. For example, Unix, Windows, JVM. So, these are the implementation domain and this is the abstraction domain. If we separate that out, we have the implementation hierarchy, the abstraction hierarchy on the left side and the implementation hierarchy on the right side. The number of classes has reduced, and not only that, if there is a change on the abstraction side, we have a new scheduler or we have a new platform. We just make small change to the corresponding class hierarchy. We do not need to have too many subclasses added for just one simple change. Now, let us look at one more example. Okay, before that, from our examples, let us make some observations. If an abstraction has several implementations, that is, we have defined some abstraction ideas for application, but then it can be used on various platforms and so on. And then the programmer is typically tempted to use inheritance to solve the problem, just add some classes in the inheritance hierarchy. But then the problem that occurs is that the inheritance binds the implementation and abstracts together permanently, and it becomes very difficult. The solutions are too complex. Any small changes require too many changes. But then what is the design principles does this kind of solution violate, that a programmer for any small change that is on the abstraction hierarchy or the implementation hierarchy just make subclasses on the same class hierarchy. If you look back to the previous lectures, you will see that it violates the single responsibility principle. Violates the single responsibility principle. Now, let us see what a programmer had to tell as he became more experienced and observed what he has been doing. He had this to say. He said, as a beginning object oriented analyst, I had a tendency to solve the kind of problems by using special cases, taking advantage of inheritance. I loved the idea of inheritance because it seemed simple, new and powerful. I used it whenever I could. This seems to be normal for many beginning analysts, but it is naive given this new hammer, this new tool somebody has learned, very simple tool, everything seemed like a nail. Very correct, and that is how many of the application solutions become complex, because of the overuse of inheritance, tend to violate the single responsibility principle, and must keep in mind the bridge pattern and make use of that. And given a ugly design, we should be able to refactor by using the bridge pattern. We must use the bridge pattern when we want to avoid a permanent binding between the abstraction and implementation. Also, the implementation may be selected and switched at runtime. So, the application can run on different platforms seamlessly. Both the abstraction and their implementation are extensible without implementing the clients. Even the code need not be recompiled. Now, let us look at another example. Let us look at the circle shape problem. The problem is that we have a circle, we have a package where we can draw a circle, and also we can do various manipulations on the circle. For example, we may stretch it, we may contract it, we may change the color, we may change the fill pattern, and so on. But also the circle can run on the browser, the circle can be displayed on the browser, on a standalone application, on the mobile phone, and so on. It is again a straightforward application of the bridge pattern. So, here the abstraction and the refined abstraction is the shape, circle shape, and the concrete circle shape, where we can have various operations like resize, change fill pattern, change color, and so on, and then the implementation hierarchy, where we have implementation on web browser, smartphone, and so on. So, here these are the classes which participate in this pattern: the abstraction, which is the interface; refined abstraction, which is the concrete circle class; then we have the implementation, which is the interface, and then the concrete implementations, which use different drawing APIs for different platforms. Now, let us try to see the code, the Java code. Here on the implementation side, the drawing implementation is an interface. It only supports draw circle given the center and the radius, x, y, and the radius. It can draw it on a web browser, that is one implementation. Another is on a smartphone, another is on a specific application, and so on. So, this is the simple code for the interface drawing implementation, and then we have the concrete implementations which implement the interface drawing implementer. So, we have the concrete implementer A implements the drawing implementer, and here for each of the methods in the interface we provide the definition, and similarly for the other concrete implementation we have the implementation for the draw circle. Now, let us look at the abstraction hierarchy. Here we have the interface shape. Here we have the abstraction domain terms or the application domain terms like draw, resize, change fill color, fill pattern, and so on. Now, this is a simple interface shape. Now, let us look at the concrete shape, which is the circle shape. Circle shape implements shape, and then it has the constructor where we provide the specific concrete implementation. The drawing API is an argument on the constructor, and that is how the bridge is established. And here in the private drawing API, we store the argument provided in the constructor. And then we have the other application specific, abstraction specific methods. Wherever required for implementation specific methods, we call the method of the class, specific class on the implementation hierarchy. Here we are calling the drawing API dot draw circle, which is the drawing API is the implementation class, concrete implementation class, and we are calling the draw circle on that. Whereas the other methods are on high level abstraction specific methods. For example, resize by percentage, change fill pattern, change circle color, and so on. Simple code example for the bridge pattern. Now, this is the client code. In an array, we create many circles, 2 circles we have created, and we have given 2 different APIs for those 2 circles. And the client just interfaces with the abstraction domain class, which is the shape, and then we call the shape resize by percentage. It will be handled by the method in the abstraction class without really invoking a method on the implementation class. Whereas, we might also invoke, the client might also invoke some methods which will require calling a corresponding method on the implementation hierarchy. We are almost at the end of this lecture. We will just stop here. We will look at some broad conclusions on the bridge pattern, and then we will look at a different pattern. We will stop here. Thank you.